Hello and welcome. So we're going to be talking about isosceles and equilateral triangles today. Now, properties. Isosceles triangles have at least two congruent sides. So if there's two congruent sides, then it's an isosceles triangle. Now, with that, keep in mind that if you have two sides that are equivalent, you also have two angles that are equivalent. And the angles that are equivalent are the ones that are opposite, right, across the triangle from that side. Right? So we get an additional property with isosceles triangles is that the base angles are congruent in isosceles triangles. So you'll notice that we have two congruent sides, and the third side that isn't congruent to the others, right? The remaining side is what we call the base of our isosceles triangle, and those base angles, the angles that form the base, right, those are congruent to each other. Now keep in mind, base does not mean the bottom of the isosceles triangle. It's possible you could have something like this, where those are your two congruent sides. The base would then refer to that side right there. All right, so do keep that in mind. 'Tis a thing. All right, now if you have three congruent sides, we call this an equilateral triangle. All right, now same idea with the isosceles is that across from the congruent sides, right, we have the angles, and it follows that all three angles must be congruent because all three sides are congruent. All right. Now, if you have the interior angle sum of a triangle add up to 180, and we know that we have three angles that are the same value, then it must follow that all three of those angles have to be 60 degrees. And this will always be true for equilateral triangles. And so always, always, always in equilateral, your angles will be 60 degrees. All right. Isosceles, they could be anything. They're just guaranteed to be the same, right? Just the same angle. But equilateral, it's guaranteed not only be the same angle, but also guaranteed to be 60 degrees exactly. All right, so example 1, it says, given each triangle, solve for x. So when it comes to anything in geometry, your goal is to figure out what is the relationship between what you're seeing and your geometric figure. So we're looking at a triangle. Specifically, what kind of triangle? Well, we see three congruent angles, so it must follow that if the angles are congruent, so are the sides. This is an equilateral triangle, all right, which means all sides are congruent. That means that your 7x plus 11 is equal to your 5x plus 33 is equal to the 8x, right? Now you're like, oh my gosh, triple equation. What do I do? It is not as complicated as it looks. You can choose which part of the equation you want to solve. Don't tackle all three at once, right? Pick two of those expressions and create an equation from those, right? So for example, I like using less terms and I like the 5 better because 5 is my favorite number. Sure. So 5x plus 33 equals 8x, right? You also could have used these two as an equation or the first and the last as an equation, right? Whatever you want to choose, just choose two of them and then solve. So I'm going to subtract 5x. So we get 33 equals 3x, divide 3, and x equals 11. No matter how you set this up, you would have gotten 11 as a value back for x. Okay? And then just as a last double check, right, you want to make sure that 11 is a valid solution to have. Because when you're looking at a geometric diagram, all of these, the 8x, the 5x plus 33, and so on, they represent lengths. Lengths cannot be negative or 0. So we're looking at that, and I say, okay, 8x. I know x is 11, so 8 times 11 is 88. That's a positive number. Huzzah, that's all you need to care about, right? Plug 11 into there, we get 55 plus 33 is 88, positive number, that works, right? Plug it in here, 77 plus 11 equals 88, positive number, right? And then you also see that they all equal each other, which it should. It's an equilateral triangle, right? And there you go. 11 is a valid solution. You're good to go. Example B. Looking at this one, we have what kind of triangle? Well, you see two little congruent marks, and then we have a third side without any marks at all. This tells us that we are looking at an isosceles triangle, right? So that means that, keep in mind, this is an angle, by the way. It's kind of floating. This is also an angle. Okay, this means that we have our base angles, the two angles that form that side with the base. So we're like, okay, base angles are congruent. An isosceles triangle. That means that if this angle is x, so is that angle down there as well. And then you know that all three angles in a triangle must add up to 180. All right, that is a property for all triangles, always true. All angles add up to 180, interior angles of a triangle. So we get 2x equals, if we minus that 104, the other side, 76. Whoops. Okay, and then finish solving for x. Multiplication of 2 is undone with division of 2, so x equals 38. And the same idea, technically we want to plug that back in, right? X is on its own, which means that the number that we solve for has to be positive, which it is. It's positive. It's not 0. It's not negative. You're good to go. All right, so x equals 38. Valid solution. It worked everywhere we plugged it in. Okay, let's do 2 more examples, just kind of make sure you get the feel of it. So first one, we have both angles and sides. Still figure out what you're looking at triangle-wise. Similar to the example A, we have 3 congruent angles. This tells us that we're looking at an equilateral triangle. So we'd say, okay, sides are congruent. All sides are congruent in equilateral triangles. So we'd say, all right, well now, I know that sides are congruent. So what does that mean for my 5x plus 65 and 6x plus 52? It means they're equal to each other. All right, then we just need to solve for x. I personally like positive variables, so I'm going to subtract the 5x over. All right, and I'm also going to move the 52 over as well. Okay, so on the right side, we have 6 minus 5, which is 1x. On the left, we have 65 minus 52, which is 13. And then that is our answer, x equals 13. There we go. Plug it back in, make sure it works. Right, so 5 times 13 is 60, plus 65 is 135. That works. And then, oh, wait, hold on. 5 times 13 is 65. 65 plus 65 is 130. Ooh, that was close. Arithmetic, I was like, wait a second. All right, and then we have 6 times 13. I'm now downing myself in arithmetic. That is 78. And then add 52 to that, and we get 130 as well. Positive number, it's not 0 or negative, we're good to go. Right? Now, if it asked me what side AB was, 130, right? You know, all of them must be equivalent. Oh, I put a degree symbol. There we go. 130, because we know they're all congruent sides. Okay, so that is x. Now, the last thing to look at is y. And we're like, okay, well, y is an angle, and we have no other angles to look at. There's 2 ways we could do it. You could say that you have 7y plus 11 because they're congruent. You know that all of them are the same thing. And then you could take all 3 of them, add them together, equal it to 180. But there's a slightly easier way to go, is that in an equilateral triangle, you're guaranteed that not only do you have the general property of adding all angles to 180, but you have the specific property for equilateral triangles as that single angles must equal 60 degrees. Right? Save yourself some effort. Literally, it's going to equal 60 because that's true for all equilaterals. And then solve. So 7y equals 49, divide 7. Y equals 7. Right? Plug it back in just to make sure it's going to work. 7 times 7, 49, plus 11, 60. Positive number, you're good. Okay. Now, example D, same process. Right? We're told that BC is x squared plus 17x. We're told that AC is 8x plus 22. Now, you're looking at an isosceles triangle. And we know it's isosceles because we only see 2 congruency marks, not 3. So we have our base side, AB, right there. Okay, so I'd say, all right, well, the 2 sides we're given were the congruent sides, which means that x squared plus 17x equals 8x plus 22, right? Congruent sides means equal values there. So I'd say, all right, well, let's solve. Now remember, x squareds are quadratics. Those require a little bit more special solving methods. You can either factor it, quadratic formula, or complete the square. I personally like factoring, so that's what I'm going to do. right? So to factor, we need one side equal to 0. I like my x squareds being positive. It makes it easier to solve. So I'm going to subtract 8x and subtract 22. All right, so on the right side, you get 0. On the left, we now have x squared plus 9x minus 22. Right? And then to factor, you're looking for two numbers that add to your middle number, combine to 9, but multiply to negative 22. Remember, that's first times last, 1 times negative 22. That gives you 11 and negative 2. All right, and because your leading coefficient is a 1, go straight to your parentheses. And then set those factors, those parentheses, equal to 0 to find your solutions. So I'm going to subtract 11 on that first equation to get x equals negative 11. Add 2 on the second equation to get 2. All right, and like any solution before, we need to check them in our originals. All right, so let's try negative 11 first. So I plug it in, we get negative 88 plus 22. That's negative 66, right? Negative lengths are not possible, which means you cannot have negative 11 as a solution. All right, let's do it again, but with positive 2. 8 times 2 is 16, plus 22, and we're going to get 38, positive number, that's fine. 2 squared is 4, plus 17 times 2, which is 34. We get 38, positive number, we're good. We could double check, right? Your congruent sides are indeed equal, you're good to go. All right, that is kind of all of your solving when it comes to isosceles and equilateral triangles. Now, the last thing we can do is just kind of use those properties a little bit more, right? More geometric properties to get to our answer. So let's start out small with E, and then we'll finish out with the harder example. So on this one, we'd say, okay, we're given two pieces of information, right? We're given X, and we're given these dashes. We're given 35, and we're given the dashes. So the dashes tell us that we're looking at an isosceles triangle. And then the one side that doesn't have the dashes is our base, right? Which is that bottom leg in the triangle, right? Now, the two angles that form along that base are congruent. That is your property of isosceles triangle. So if we know one of those angles is 35, you're also guaranteed the other is 35. And then you know all angles in a triangle add up to 180. So 180 minus our two 35 angles gives us 110. That tells us 110 is our third angle there. Now, the thing we need to find is x. X is this angle outside, but look, that's all along the same side of a line. And if you remember, everything along the same side of a line adds up to 180. And if I know part of that 180 is 110, then we're essentially going backwards. 180 minus 110, 70. Right? So x equals 70, and you're good to go. Right? And then x represents that positive angle, so 70 is a good solution. All right, example F. Almost done. Same idea as before. It's going to be easier to work with a number than it will be an expression. So I'm going to start at the 55 for this one. All right, so when I'm looking at this, same idea. I'm looking at the 55. 55 is this angle down here. All right, now what I notice about that is that we have those two congruency marks, which means we have an isosceles triangle, and that third side's the base, which means this is also 55. Now keep in mind, I have some students who try this, is that they try to do the 180 thing with those angles. Keep in mind that that is your straight line there. 180 is all of those angles together. That extra little snippet outside the triangles would also be included, right? That's not what you want. You can't use the 180 minus there, all right? Which means we have to go for the third angle in our triangle, all right? So I'm going to say, all right, I know that's 180 minus my two 55s. So that should be, what, 70 degrees? Okay, and there's one more really important piece of information we're told about that angle over there, is that I know that on those two triangles together, that's going to combine to give you that box, which is a 90-degree angle, right? So if the whole thing is 90, and I know part of it is 70. What's this part supposed to be? Has to be 20, because 20 plus 70 is 90, and if the whole thing is 90, it has to be 20 to fill up the rest, right? And then now we're in the top triangle. We say, okay, well, double congruency marks again, which means your base is that side right there. And you know that base angles are congruent. Here's your other base angle, so that's also 20. But we know in addition to that being 20, we also know that angle is 2x plus 12, meaning they have to be the same value. 2x plus 12 must be equal to 20. And there's your equation, right? Now you're able to solve for x minus the 12 over 2x equals 8. Half of 8 equals 4. Right? Double check it by plugging it in, right? 2 times 4, 8 plus 12, 20, positive number, you're good to go, right? And there you have it. You are solved and you are finished, right? So that is isosceles and equilateral triangle properties. Thanks so much for watching.